I think most of you have already joined, so we can we can start, right? Okay. So up to the last class, do you have any doubt, anyone, or any question that you want to ask? Any question or any doubt that you have up to the last class? So in the last lecture, basically the fourth part from metal forming and press work, this particular second module, we have covered that. Okay. So like there are five different parts in this second module itself. Okay, in the metal forming and press work operation. So up to the last class, that means in the last class we have covered the extrusion one. Okay, so prior to that already all those different forming processes we have seen. Okay, so forging, extrusion, all those things already we have discussed. Okay, and up to the last class whatever we have discussed, those are basically like bulk deformation processes. Okay, and now today in this class we'll be starting the last part, that will be press work. Okay, and now this press working, this is also known as the sheet metal operation, and they are somewhat different from the bulk deformation operation. So these also sometimes, as why we are studying this together, metal forming and press working process, because sometimes this press working process or sheet metal working process also is considered under forming process itself, where sometimes what we do in some of the processes you will see, like the whatever the raw metal which will be in the form of sheets only, because we'll be discussing about metal press working operation, which is also itself is known as the sheet metal operation. So you'll see in many of the operations, just like the forming operation, will work with the sheet metal, which will be our workpiece. Okay, and basically we'll be giving certain shapes to it, and that's why sometimes these are also considered discussed with respect to metal forming operation. And now later on you will also see that sometimes some piercing, banking, those kind of processes in operation, okay, also known as the press working. So basically what happens, you will see some scraps are also involved, and that is how basically they even though we actually discuss with respect to metal forming operation, sometimes even we categorize press working or sheet metal operations, sheet metal operation as a part of forming operation, but still there is there is a thin line between them. Okay, they are not entirely same. Okay, so the other deformation process, basically whichever we have discussed, those are categorized under the bulk deformation processes. Now here in the sheet metal working or the press working, they are actually not bulk deformation process. Okay, so this is how they are, that certain, even though we study or group them sometimes together, but still we have got certain differences. Okay, and in some of the processes you will see, in the process itself we will be having certain scraps also, which is not a quality characteristic of forming process, because we know generally forming process, they are they constant volume process. Don't have any scraps and all. Okay, and within the wastage is either you can say negligible or very minimal. Okay, so that is the characteristic, one of the basic characteristics. We actually play with the shape. Okay, with the workpiece. So today that is we are going to discuss about that particular topic only. Different topics which will be covered under press working. Now, why these sheet metal operations are also known as press working? So basically, you will see here what happens in most of the operation, which are primarily done by this under this heading of press working or sheet metal working. You will see most of the operations will be like will be having like we'll be using presses. Okay, we'll be using punches and all. Okay, the punches was to get the particular work done. Okay, get the particular product. That's why these are also known as the press working. Okay, so I hope the initial things you have understood. Okay, how the press working or metal sheet metal working operations are different from the conventional forming process, which are the bulk forming processes we are talking about. By this time, whatever forming processes we have discussed, basically those were the bulk deformation processes. Okay, so now how we can define this press working or sheet metal operation? Now, this sheet metal operation, basically they are by far, you can, if you consider, okay, then they are the one of the cheapest and very fast way of complete manufacturing of particular component. Okay, that is important. So here, in most of the cases of press working or sheet metal operation, you'll see it itself, that particular process itself will completely manufacture the component. There will generally there is no secondary operation etc. involved, and most of the time even assembly also is not even involved. Okay, that's why we can say that this is one of the cheapest method and very fast also. You'll see, and what we can do, we can manufacture the complete part or complete component in the process. Okay, or you can say the otherwise if you say that means the products that we obtain or that we work on particular component. Okay, and sheet metal working. So definitely press working or sheet metal. So here, what will be our work material? What will be the look of the workpiece? Basically, it's a sheet. Okay, in the form of sheet. Okay, that's why the operations are known as sheet metal operation. Or okay, so now basically here in this particular case, in the previous cases what we have discussed, the workpieces may be in the form of loom, billet, etc., slab, etc., etc. But here we are will be the workpiece itself is a sheet metal. Okay, and now how we can define this sheet metal? How it is different from the slab and all, whichever we have already discussed. Loom, billet, you believe I believe all of you can very easily distinguish them. But how we can distinguish the sheet metal on or slab? Okay, or when we will be calling a particular workpiece, a particular shape of a workpiece as a, we'll be considering like a sheet metal, it's a sheet metal, or when we have to discuss it as a slab. So now this sheet metal generally it's a considered to be a plate whose thickness is generally less than almost about 5 millimeter. So up to this 5 millimeter range, or you can say below 5 millimeter actually. Okay, so below 5 millimeter range, generally, if the plate thickness is below this, we can consider that workpiece as a sheet metal. Okay, and most of the time you'll see these sheet metal working are actually cold working operation. We'll see as if you're talking about sheet metal, so thickness of it is from this particular value, it's a high thickness or it's a low thickness, small thickness is definitely it's a very small only, correct? Thickness is not high. So now if we go for hot working of it, so very easily you can say if we think of a particular sheet metal in the form of a sheet, and if you heat it, then like thermal distortion or deformation will be very much high. It will be like it will be all damaged. Okay, even if not structurally, maybe like some shape, etc. Everything might it may even still. Okay, so now in this cases, generally they are cold working operation, and that manufacture low cost parts with very high volume. So very high volume is high volume and at a fast rate. This high volume and fast rate, okay, faster rate of production. These two are one of the main characteristics of sheet metal operation. Okay, you can distinguish like how this sheet metal operation whenever we perform it. Okay, then they are these two high volume of production and faster rate of production. They are the two main characteristics of it. Okay, so I hope the introductory part of this sheet metal working, how we can define what is sheet metal, okay, and what we can do with the help of this press working or sheet metal operation. I believe it is understood. Now, the sheet metal operation, which also known as the press tool operation. Why press tool? Basically, you will see in most of the sheet metal operation, actually, we use press tools. Okay, that means punches and all, punch, different press. Okay, so which can press. Okay, so we use them. Now, the different press working operation or press tool operation, okay, which are carried out by press tools have been classified on the basis of the type of stresses introduced into the component. So now, depending on how we are performing that particular operation and during the process of operation, how basically which type of stresses are being introduced within the component, we categorize the different press tool operation or the sheet metal operation. So now under this heading of sheet metal operation or press tool operation, there are many operations which are carried out. Okay, in the previous cases, what you have considered, if we are discussing about suppose forging, it's like two three types of forging only. Suppose drop forging, smith forging, that swaging, etc. That kind of different processes are there. But here in the case of press tool operation, there are a variety of workings involved, and how we can categorize or what are the different stresses introduced within the component during the press tool operation, we will see now. Now in this particular figure you can see, so in the left hand side we have shown the different operation. These are only sheet metal operation only. Okay, so or press tool operation, so different sheet metal operation, and what kind of stresses are being introduced within the workpiece during that operation, or what is the primary made of making the particular deformed part within that in that particular sheet metal operation. Okay, so now there are as I have already discussed, there are various types of sheet metal operation like shearing, flanking, we have piercing, trimming, saving, notching, nibbling, etc. So in this category, whatever discussed, okay, the main stress introduces the shearing stress. Okay, we basically shear, like shearing is the main stress responsible, and actually by shearing action in this particular planking, piercing, trimming, shearing, saving, etc. So shearing stress is the responsible one to manufacture the part. Similarly, we can have stress forming of different components in different components in different sheet metals. Okay, in the stress forming, the stress is the tension that is developed. Okay, similarly, we have different other methods like coining, sizing, hobbing, etc., where the stress is the compressive stress or the compression is responsible. We also have drawing, spinning, bending, different statements, forming, embossing, etc., where both tension and compression are the stress which are involved. Okay, so this is how we can categorize these different sheet metal operation, a number of them in the it categories, like we can categorize in terms of the stresses which are being introduced. Okay, so up to this much, anyone having any confusion? Or if you have understood, let me know. I'm just waiting for one or two people's reply so that I can understand that whether we have understood the things or not. Okay, thank you, thank you. So now, by this time, we have said that basically in the sheet metal operation or press tool operation, basically the workpiece is sheet metal in the form of sheet. Okay, and now what we are doing, so they are kind of forming operation only we are talking about. Okay, and now in those cases, what basically we do, we basically save them, correct? So if we don't consider the suppose only the cutting, that kind of operation, metal cutting kind of operation, sheet metal cutting. Okay, so apart from that, we also have to save them, and in those cases, previously also we have discussed what are the limits we go for. Okay, what are the different limit of stresses, okay, or the strength consideration already we have discussed in the previous discussions. Okay, and now if we're talking sheet metal operation, there here also there are like one of the we have to be very careful while designing the setup for doing the sheet metal operations and all. Okay, and there is a particular phenomenon known as the spring back of metal, which is one of the concern, and which is one of the, you can say, concern that we have to address whenever we are going to design the whatever is the sheet metal forming of the setup that we have. Okay, and now what we know, we already know that whenever we deform metal, so initially what happens? Initially it is deformed plus like elastically, it deforms elastically. Okay, if you can recall the stress strain curves, okay, I believe all of you already know about stress strain curve. So stress, here you have the strain. Okay, so if you consider that, then if right now we are talking about brittle material, or we are discussing about different these processes with respect to ductile material? Can anyone tell me whether we are interested in working with ductile material or brittle material in mostly in most of the forming operations? So generally we work with the ductile materials and all. Okay, and now you can very easily, if you're talking about sheet metals, all of you already know about the thickness. Okay, we have said that generally consider a metal plate as sheet metal. Okay, whenever its thickness is less than this limit, consider as 5 mm as the 5 millimeter as the limit. Okay, so in most of the cases you will consider, you'll encounter sheets of like 1 mm, okay, 2 mm, that kind of thickness. Okay, and now we already know if we are like applying load on a particular, or if we are talking of deforming a particular metal, okay, so initially it gets deformed elastically, okay, and then only we reach the plastic stage. And plastic deformation is a like permanent deformation, permanent kind of deformation, but elastic deformation you already know, so it's a not a permanent one. If we remove the load, basically what happens, elastic, whatever is the elastic component that we have, it gets back. Okay, so now, so these are the two stages. Okay, initially it will get deformed elastically, and then it will get deformed plastically. Okay, now when the applied force is removed, what basically happens? The plastic component of the deformation. So we have seen that basically two components are there. Okay, one is the elastic component of deformation, another one is the plastic component of deformation. Now the plastic component of deformation, it will remain permanently. Okay, there is no problem with that. But the elastic part, it tends to spring back to its original shape. And that can sometimes, if we don't consider this particular spring back effect of metal, this may hamper the whatever is the whole setup, or you can say the ultimate the product. Okay, so now that means in our case, in the case of all the sheet metal operations and all, okay, so spring back of metal, it's one of the prime concern, and it will be there. It's a, in the deformation process, spring back of metal will be there due to the physics inherent to the metal deformation itself. But we have to take care of it. We must know how the metal spring backs at a particular, how a particular metal spring backs, okay, at a particular that operations and all. Okay, and that knowledge of spring back effect of a particular metal in a particular process is very important, so that we can take care of the final required shape. Because see, the final product, okay, the final product will definitely have, it has to meet certain specification, correct? It will have like the specification in terms of, definitely apart from quality, it has to like all those dimensional requirement, okay, tolerance, etc. It has to be within that tolerance level, okay, so as to be acceptable, okay, otherwise we have to discard it. Okay, now if we fail to consider the spring back effect of this particular metal, then there may be some problem. Now what is the spring back and how we can see that? How we can, in the with respect to the stress strain curve, what we can see? Okay, so that we will see. Now in this particular figure, what we have drawn a stress strain diagram. Okay, so along the y-axis, you already know how to draw the stress strain diagram, and I believe by looking at the look of the stress strain curve, all of you can know whether it's a ductile metal we are talking about, or it's brittle metal that we are discussing. Okay, I believe all of you can very easily know. Now, in this case, if we discuss with respect to this diagram, okay, now OA, in this particular case, OA is the stress, okay, that is applied on the material, and in that particular case, that means at the application level of this much amount of stress, basically it reaches a point P. Okay, and under this particular consideration, it has a strain of OB. So if you drop this, okay, so basically this much amount is the flight due to this particular stress. This is the strain that is there on the particular metal. Okay, now when the load is removed, now basically what happens, due to the spring back effect of it, okay, so when load is removed, the metal spring backs to the position C. Now, so I believe all of you have already studied the hysteresis curve also. Okay, now this is the loading configuration, and when loaded, it is following this particular curve. And during that time, basically this is the strain. And during unloading, what happens actually? Now, when the load is removed, the metal spring back to the position C. And if that is happening, what is the final permanent deformation that we have? This much. So this much amount of deformation, which is due to the spring back, okay, this amount, okay, initially it was under the stress of OA, it was OB up to this much, okay. Now, if we remove the load, okay, these figures are exaggerated, okay, but this kind of phenomenon will happen. So it will come back, spring back to this particular position, okay, up to this particular position, say, and this much amount of this is the amount of spring back, and after that is happening, what is the amount of deformation, permanent deformation that will be there? It will be up to this much only, OC. And this CB, this is C, okay, this is O point, this is C point, this is B point. So this CB is the amount of spring back, okay, and OC is the amount of permanent deformation. Okay, these are not standard rules. Okay, you should not use PG etc. to denote permanent deformation. So just for understanding purpose. Okay, and now this OC, this CB is known as the spring back. Okay, and this amount of spring back, it's a property of the material, and this is dependent on the modulus of elasticity of the particular material. Okay, so while looking, we can have a search for this amount of spring back for the particular metal. Okay, and how it is related with respect to the modulus of elasticity? Basically, higher the modulus of elasticity, lower would be the spring back effect. Okay, so this is how basically this spring back is there. So now I believe all of you have understood why we have to know the, we have to have the knowledge of spring back for a particular metal. Because what happened, we the after spring back, the amount of permanent deformation that is there is only OC, and considering that only, we have to basically design our all the setup and all. Okay, we can expect that basically what happens after the process over. Okay, if we remove the load, that means this kind of spring back will be there, and this much only will be the amount of permanent deformation that will be there. And this is the this amount is basically responsible for giving the final required shape to it. Correct? Otherwise, this much is already spring back, and there is no and this is inherent to the physics itself, and it will be there for a particular metal, which itself is a property of it. So, have you understood spring back effect in metal and why it is a concern, and why we have to take care of it, and how we can deal with it? Let me know. Let me know whether you have understood the concept of spring back or not. Why it is important, how to deal with it. Deal with it means what are the why it is the knowledge is required. Okay, what is the problem? Okay, now in the next class, for today we'll stop here. Okay, so in the next class we'll be discussing about the shearing action, how basically the metals are being sheared and all. Okay, so this shearing cutting operation, or the shearing of action, how basically stage by stage it is happening, it will happen. Okay, and what are the characteristics, those things we will discuss and all. Okay, apart from some other thing. So with this basically today's class we will conclude here. If you have any question, any doubt, you can ask me. Okay. Yes, happy birthday, Bhargav. So, happy birthday, Bhargav. How are you? Okay. So, if you have any question, you can ask me. I'll be very happy to answer it. Okay. And if you don't have any, if you don't have any question, then just let me know whether you have understood or not. Okay, so I hope all of you have understood things which are very easy only. Okay, and we'll stop here. And once again, happy birthday to Bhargav, and thank you everyone for joining the class. Thank you. Okay, I'm stopping the recording.
Sir,